Okay, so this is operator overloading. Okay, so let's actually modify this code a little bit. Let me cp box.h to box2.h. box2.h. So what I'm going to do here is I define another class called box2. And of course, I have to modify the constructor here. Okay, I have to modify all this to box2 to make sure I have it. But the most important things, first I'm going to get rid of this. All right, so now you can see I should be able to modify the A box. And what I'm going to do is that I'm going to set the value. I'm going to set the value called, I'm going to change a value called double set length. And I will say length, oh, sorry, void double new length. And then I will say length is equal to new length. So I have a new function I define, which I can set the length to be a new value. Okay, and what I'm going to do is that inside here now you can see I allow this should be box2 right now. By the way, operator overloading. This is box2. So I allow this A box to be modified. So inside here, what I'm going to do is this. I'm going to say A box dot set length. I just defined this set length. Yeah. And I'm going to, the value is going to be A box dot get length times 2.0. So essentially, in this function, every time I do a comparison, I increase the number of lengths by 2. Okay, so now you see that now I have a function which I can modify the A box, and then I compare. And the thing is that, wait a minute, but this might actually also change this semantics, because after this is going to be changed. Okay, so once we do this, okay, Control X, Control C. Now I'm going to modify box ex2. So I'm going to cp ex.cpp to ex12. I call it box2.cpp. Okay, here I'm going to include, of course, I'm going to include box2. And over here, I'm going to say vector box2 boxes, box2, 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 box2. And here I have box2 as well, okay? And okay, over here, I'm going to execute the program as it is now. Hold on for a moment. Is everything okay? Do I need to change anything? Okay, so right now, let's try to compile this program first. GCC minus std is equal to C++17 ex12 box2.cpp minus O. I call it zoom box. Okay, because we're actually running this program in Zoom. Okay, now I have error. Okay, because I make the mistake in box 2. I thought oh, this place. This should be box 2. Get length. No static member. Hold on 1 second. Let me check what is this error message. Oh, I make a mistake. Bad mistake. Sorry about this. Okay. Wow. What happened? Why I have so many linker fail? Why I have this problem?
Is it because you're compiling using CC?
Oh, yeah, exactly. Thank you. I was not thinking. All right, now I'm happy. Sorry about that. Zoom box, okay. Okay, so the smallest box has a dimension, this one, but let me actually try to compile the original program, okay? The original program is this one, right? And then I call it, this is original program, EX120. Okay, there, you see there's a difference. That this one has 2. Because it's double, the length is double, and the original one is 1, right? So I'm using that reference. Let me go back to my program again. This one. Because you see, when you call this function overloading here, that this will actually double the length about small box. And therefore, the small box, when you actually get its dimension, get length, you will see that double. But now I am going to change my code a little bit to change without that reference. So I'm going to run this program and get rid of this one. Okay, so here I'm going to do get rid of this. Okay, get rid of that %. Let's see what would happen. I hope it will happen exactly the way I expect. Okay, this one I call the zoom box without int %. Okay, without int %. Now I recompile it. Okay, let's try to run that program. Zoom without. Okay, you see it go back. You see the difference. Let me try to run this program together so you will see what happened. The version with %, is like this. And then this is the original one. It's like this. You see that if I do without the %, and the outside box is the same as before, which means that the impact within the overloader operator when I try to increase the, let me actually show you the code. Yeah, it's this piece of code.
Wait, so when you don't put the change of doubling the length isn't permanent outside
Exactly,
of
exactly.
comparison.
So yes, exactly. Means that you don't put the ampersand, the change of this is only within the object.
And so you
Within
want to
this,
put the and right after the object. You want to keep the change.
you want to keep the change. If I add the ampersand, right? That means if I change here, I really change that A box. So there is a not, think about this. Let me use my PowerPoint, okay? So the difference is this. Let me use my insert new slide. Okay. I love this real-time drawing. Okay. So this is the object called box, all right? So if you want ampersand, what you have ampersand means that this is another box. This is box 2. Let me just say, this guy is called box 2. But when it go into the, after it being called, it's called A box. Okay, so basically, where do I get my stuff here? Hold on 1 second. So with ampersand, when you call, that you really bring this object, you bring this object into the space here. So whatever you're doing here, that after you finish the call, is actually returned to the space. So the length get double, so it will get double outside as well. But when you do the call without the ampersand, which you really, what you really are doing is just copy the value and go in. And then the outside is still outside. And therefore, whatever you're doing here, you're doing XYZ stuff. And whatever over there is still the same. So this yellow is I call it without the ampersand.
And I'm confused because on your code, if we could go back to where we were talking about where this and is,
Right.
you put that and after box 2, but I see that you're doubling A box's length. Why is it after box 2 when A box is the one feeling the effects from this?
Okay. So if you think about box 2 and, this A box is, I use the term reference. Okay, this is a reference. So now I want to tell you that there is another way you can do this. Is using a star, right? So if I do box 2 star A box, what does that mean in C?
Isn't that like the point?
The pointer, right? The pointer, the address. So if I do box 2 star A box, this A box is actually the address of the object, the address of the object. So if you give me the memory address of the object, in other words, you're giving me the memory address. Where's my famous slide somewhere? Yeah, if you give me the so if I use a star, which is, how do I actually represent a pointer? Let me use this as a pointer. Blah, 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 using this one. Okay, this is my pointer. Let me change the color. So you're passing the if you use box 2 star, you're passing the pointer into this object. And then I'm actually going through, this is C, only C programmer understand what I'm doing. So over here, you're not going to call A box dot length. You're going to say this syntax, A box hyphen greater than, this is the pointer sign, and to call this function. If this, you write it this way, this is the way you're going to do it. Okay. So in some sense, that C++, let me tell you that this is a little bit ugly. C++ want to use the same kind of thing. They want to avoid using, in some sense, they want to avoid using this type of stuff, construct. They do this, but they want to still do call by reference. so they use this construct. This construct means that it's a reference, but it's not a address pointer. And inside, you can actually call it and then to get it. But by the way, there is one thing which I will review for all of you, regardless whether you're familiar with this, is the difference between call by value and call by reference. Okay. And this is a very important concept because it really depending on whether, if you call by reference means that all the changes you made within this function or member function will be observable outside of the scope of the function. But if you do call by value, that means that anything you change is not going to be observed outside. So that's the difference between call by value and call by reference. The C language was designed to be everything is call by value until people introduce the concept called pointer, which then you can implement the concept call by reference. Okay, is that somewhat help you to understand that why we want to have this ampersand here?
Yeah, I'm just last question as it pertains to this is when you were talking about the pointer and the C analogy, you put the star in front of a box.
Right.
But here we're putting the and sign after box.
Exactly.
2.
Yeah.
Why exactly are we operating on box 2 instead of a box?
Oh, you're talking about, I know what you're saying. You're saying that why am I not, hold on. Why am I not doing like this? Is that right?
Exactly. Like
Yeah.
why do we do it the other way now?
Okay. A quick answer before I run the program. I think that's a convention because we want to put this in here to say that what is a box and this is type. So we basically think that the whole thing, box 2 ampersand, is an adjective to describe the attribute about a box. It's just like in C that we usually do this way, right? If you want to put a pointer, we put a star here, but you can also do this way as well. Okay, I think it's a convention.
Oh,
But
I didn't know we could do that.
yeah, let's try compiling and see if the compiler will throw us out. Okay, because as I said, for programming, if I never written the program, I don't know what I'm talking about. I might shoot my own foot. Let's try to do this. Okay, so let me do this. Let me try to compile again. Okay, I want to have that ampersand. So it's a zoom box, right? Yes. Okay, so this one now it works. So let me change that. Let me change this. So now I'm doing this way, right? And let's see whether compiler like it. But before I run that, I want to compare the results. So I want to run the program once. Okay, here's the result. So I'm compiling it again. It looks okay. See, the compiler, they don't care whether you want to do one way or the other. So it's convention. I think I just using
so that
this
white space is almost just to denote that a new variable is coming, but that and means whatever comes next it feels the effect of the ampersand.
Yeah, exactly.
Okay.
Exactly. Yeah. So let's do another exercise since we're here. Let's use this convention. Okay. I use a star, right? And because I use this convention here, I have to use this one, a box. I have to use this convention like this, okay? And I have to use this one, right? And this is box2.h, and where's my favorite C program? Okay, and here I have to change as well. Wow, this is how I'm going to do that. Okay, I'm going to do ampersand because it's a pointer, right? I'm going to do this one. Let's see if this even compile. I'm doing something kind of dangerous, okay? Not recommend, but I'll try to do that. Yeah, it works. Okay, fine. So let me run the program. What do I call this? Zoom box. Yeah, the output is the same. So let me show you what I did. I actually changed the syntax and such that it is passing in instead of the reference, but I'm passing in as a pointer. It's a memory address. And then I use this notation to call the function. But you can see that I put that star in between, but I can do this way. Let me see if, I bet this is okay. Yeah, it's okay. Or I do this way. I mean, whether this is good news or bad news, I don't know, by the way. So which means that C compiler can accept anything. Whatever you want to put is fine. Okay. Yeah. Okay, now I'm confirmed that I can play around this way. All right. Does that help you to understand the language and different option you can do?
Yes, can you review with me when you have a box hyphen greater than that pointer symbol? I remember that we used an alternate notation in C last quarter, but I forget what that alternate notation is. Do you know it?
Okay. So so this means that okay, depending on how you define. If I define it this way, I define, let me do this way. Okay, let me actually using this notation here. So I'm looking at this part of a declare. Right? What is a box? A box is a star means a pointer. So means it's a pointer to an object with a type box2, right? So a box is a pointer, or you can say it's an address. It's a memory address of pointing to the first byte of the location, the memory location for box2 object. Okay, you see that I'm actually transferring myself into the C syntax because I started using the term memory address, because that's for those of you who unfamiliar with C, that is very important why we designed the C language. That C is the only language pretty much besides assembly language that I can actually be able to address real hardware memory in the programming, in a high level programming language. Okay, so this A box represents the memory address. So when I use this is not an object anymore. So whenever you have address, that in order for you to call the function within that object, that you use this notation. Whenever this is a pointer that you pointing to something, then this is this address. Okay, so let me tell you another example, which is now I'm going back to the I'm actually going to change the whole thing. I will implement this as a box3. Sorry about that. CP box2.h to box3.h. Okay, I'm actually going to change completely back to C. Okay, I'm going to get rid of this. So instead of box, I call it struct. Okay, and I don't have a private anymore. I still have length, width, and height. And I'm not going to have this set of stuff because this is just member function. I don't want to deal with a function pointer today. Okay. Okay, so I have a box3. Is that what I want to do? Okay, fine. I'm going to do Emacs my box 3.c. Okay, I'm going to do include std io.h, include stdlib.h integer main void. Okay, I'm going to define a struct. Oh, I forgot one very important thing. Can somebody help me? What's the name of my box3? Is that box3.h? Is that right? Let me just double check. Yeah, box3.h. Yes. Okay. So I'm going to define control x2, control x5, box3.h. Okay. So I have it here in front of me. Struct box3. I call it my box. Okay, BBB. Okay. All right. So I can do this way. I can set. Of course, I need to. Let me just do a trick. B0. M BBB size of BBB. This should set everything to be 0, but I want BBB dot length is equal to 1.0. And I have height is equal to 1.0. Okay, so I'm set over here. All right, so I'm going to do a function called printf. Wallen is equal to percent. What should I do here? Percent F or percent L? Wait a minute. What's the double? LD, right? I forgot. Should I put LD or F? Okay, I'm going to just put F for now.
For float, yeah, F.
Yeah, I forgot. There's something for double as well, but that's okay. I'm going to do F.
D, I think, but yeah.
Yeah, percent LD. I think D is that's the integer. Okay, so I'm going to say BBB dot length times BBB dot width BBB dot HEIGHT. Okay, let's run this simple program to get back to where we are. Okay. Okay, I'm going to say GCC my box 3.c minus O to my. Just say my. Wait a minute. What happened? Unsigned long. B0. Okay. I know there's one thing I unsigned long. Okay. All right. I'm going to deal with this very quickly. Okay, let's see if I can pass that compiler error. What happened? Void star strings.h. Okay, sorry, I have to do strings.h. Strings.h. Okay. And I will do void star just in case. Okay, so I can run this program. It print out the volume to be 2.0. Okay. All right, so now I'm going to change the convention. I'm going to define another variable called struct box3 star ptr bbb. Okay, so you see that now the PTR underscore BBB is a pointer to struct box, or it's a pointer to a object if you change struct to class. So now I'm actually going to do here is that I'm going to assign PTR BBB is equal to M BBB. This is a way to say, because I add ampersand, I mean the address of BBB, and then assign to this pointer. And now I can rewrite this line of code. I change this to PTR BBB, and then use this notation. Again, PTR BBB. So one is dot, one is just hyphen greater than. I usually just call it pointer notation. Okay, you compare this two, this line and this line. They're basically doing the same thing. It's just one using the original BBB, one is using the pointer to the BBB. And of course, if I compile the code, yeah, both of them will get exactly the same result. Okay. Does that help you to understand these two different notation?
Yeah, I get what you're saying.
Okay, all right. It's complicated, but that's the programming language construct. So I emphasize that for learning programming, there are two perspectives. One perspective is try to understand the difference here, so you can understand other people's code. But on the other hand, when you write your own code, you have to choose, which one you think is more readable, is more expressible. And sometimes, like if you compare those two, personally, I think this is more confusing. This is number one is much longer, and it has a lot of the pointer sign. Whenever you have that pointer notation, it could look pretty. For people who are unfamiliar with the pointer, sometimes they could easily misinterpret. Okay, all right. I hope this address. By the way, is there any question about this notation? This is an excellent question. I'm so happy to be able to show you the difference. Are there any questions related to this before we switch to something else?
Yeah, Professor.
Yes.
The line above the print, PTR BBB equal to, that line. What's the ampersand BBB? So it's going to grab the value?
No, this is not a get a value. So this ampersand here is a special notation in C or C++. It's the same thing. They're the same system. This essentially say what's the memory address of BBB. Okay, let me bring you a PowerPoint slide. Okay, I'm going to show you something which is I did this long time ago with ECS 40. Okay, let me see. Maybe my ECS 40, ECS 30, they all have this. I know I talked about this the first class in ECS 40. It was horrible, so I did decide not to do it this time. But my first lecture has like 100 slides or something like that. I'm going to show you what I did 8 years ago. Okay, you should feel thankful that you didn't go through that process. I kind of regret doing this. Okay. But the first time I was doing here. Okay. So wait a minute. Can you see my slide?
Yes.
Okay. So so in C, that when you make a function call, right? When you have a variable, the variable is going to take some memory space. All right. So for example, in this example, the function is called scale. And if you call the function by two number and you get to xn, what you have is two pieces of memory and you pass into that. Okay, that is just a regular function call. This is call by value because you copy the value from the left side to the right side. Okay, but I want to tell you what, go back to here. Can I get out of here? No, I want to end the show. But here is something called call by reference. So call by reference, instead of call by value, what you have is you pass the address of this. If you see that over here is a num1, you actually call using and num1. And what and num1 really means is the memory address of the first byte of this light green value. And also and num2 means the address of the first byte. And similarly for mx and mn, okay? So when you do call by reference, let me see if I have a code segment. I actually put it here. You see I have all this ampersand over here, but I want to see that example. Okay. Yeah, I'm sorry, I couldn't find the exactly slide. I want to show you the code segment. But this, whenever you have this, you're really touching the memory. That represents the memory address of the first byte of that variable or object or whatever it is. That's the ampersand means.
Oh, okay.
In this context.
Oh,
okay.
Okay. Also there for the asterisk is the reference.
Yes, exactly. If you let me show you this slide since you asked a question. You see here that if you have okay, now let's use this one. This is a little bit too much for some of you, but here's a function. Okay, look at this function. It's defined as integer x, right? Integer x is x. It has some memory address, 4 byte typically. An integer in a typical operating system is a 4 byte of memory space that represent this integer x. So if you do mx, which is the address of the x, then basically you can print if you print this. By the way, why don't we just copy this code? I want to run it. I know this code is quite interesting to run. Which is, where's my? Okay, so I call this code pointer. I call this code pointer.c. Okay. Okay, so this is a code I just copy over here from my slides. So you can see my slides. All right. Okay, so I have this value here, and let's try to run this program. So just to let you know the program is doing, first one, it print out the memory address of the first byte about x. You will see what it looks like, all right? And then it will ask you to enter the value for x, which I will enter as an integer. And then it will print the, this is hard. This is actually torturing even for me. This is basically say x is an integer you just enter, and then I will casting this x as a pointer to another integer, and then I try to star it, and then that is the value I'm going to put here. Do you see that? I'm kind of moving a lot. But let me compile this code. I will tell you that the trick about this code. This is interesting. If you understand this code, you're not afraid of pointer anymore. Okay, so this is my medicine for those C programming. You don't like pointer. This will make you either like it or never want to touch it again. All right. So pointer.c minus o, I call it PPP. Okay. Let me just make a real name. Pointer test. Okay. What? There's a lot of.
There's a like a quotation mark missing from the last.
Thank you. What did I do? Here, right? This one. So when I copy and paste, I must forgot something. Like this? This should work, right? No, I have a lot of warning. Let me check. Because it's different version of C compiler, and I haven't run this for 6 years. But this is all warning, by the way, which means that I still run. But let me actually try to get rid of that. It's expecting long. Okay, that's fine. This one is easy. I can just take care of that as a long. Okay, I will get rid of a warning one by one. Okay, now one less. Let me see. It says I treated Unicode. What, line number 3? I have a space. Where's the line number 3? Oh, there is a interesting space there. Okay. I'll have 2. Okay, this one integer star cast integer. Fine. That's I am okay. I know how to get rid of this. So what I'm going to do is this one. I'm going to do casting. Can I casting as long to make it okay? Yeah, I only have a 1 left. Okay, this LD, okay. If you like that, no problem. So see, I just want to tell you that in C, if you casting enough, you can get rid of all the warning. Okay, now the compiler is completely happy, so let me try to run this program. Pointer test. So this address, okay, this address is the memory address of the integer x. Okay, it's not the x. When you say mx, it's printing the address. That's the address. Okay, so now it's asked me the value, right? If I enter a value, say 1, what do you think if I enter 1, what the program will behave? It will give me a segmentation fault or some kind of core dump. You see, segmentation fault. Why is this? Because I try to use in the code, I try to use this x, this 1, as an address, and I try to modify the address, and which, if the address 1 in the memory is a privileged area for operating system kernel, and therefore if I try to do that, the operating system kernel will detect you try to modify something which is very protected. So that's why it doesn't allow you to do that. But there is a trick you can do, is that if I run this test, when it asks me to enter a value, I will enter 140.732.73.0444120. I enter exactly, wait a minute, I enter the wrong address. I should. 3910232. Okay,
you missed
this is
you put 30 instead of 03. Love that.
I'm trying to follow this line actually. Let me see. 3270. Is that okay this time?
Yeah.
Okay. Still okay. You know what? I make a mistake, I realize, because now I know why I have that problem. But I'm going to change this to long. Do you know why I get that segmentation fault? Because when I run this program early on, 8 years ago, I was running on a 32-bit computer. 32-bit computer, that integer is 32-bit, address is 32-bit, and the long is 64-bit. But now I'm running on my current machine is a 64-bit computer, which I have to use a long, which is why I got that issue. But I think if I do it this time, I should get it to work. Oh, now I have another set of problems. Let me see. Integer of argument. Okay. Line 10, 12. Line 10. Where's 10? Okay, here's 10. This should be LD. Then this should be long. Am I fixing all the problem? Let me
It should
see.
be LX after printf. Oh.
Let me see. LX, you're exactly right. This should be LX, this should be LX, right? Okay.
You're good again.
Let me see. It's a compiler happy. Now the compiler's happy. Thank you for the class. Thank you for the tips. Okay, so now I get this one. Now I enter 1407 3283 682524. Wait a minute, I missed one digit. 8368252424. Yay, you see that? I won't get a crash because I'm actually entering the address itself. So I'm entering the address as a value into that, then I can avoid the segmentation fault. So let me actually go back to see the notation. So number one, this is a long, which is 8-byte memory somewhere in the memory of your machine. And then what I did is that this line, when I using MX, this MX is just saying that what is the address of that 8-byte. In fact, it's the address of the first byte of that 8-byte. That's MX when X is a long. And then I'm asking people to ask the user to enter the value of X. So this is a typical C syntax when you want to enter a value. So then this line is probably the most tricky one in the whole program. So this line basically say, in fact, I think right now you don't need this one. You don't need, where's my cursor? I think right now you don't need this part. So this part, what I'm doing, X is actually a long, but I'm actually casting X as a pointer. So I'm actually taking whatever value you just enter as an address itself. And then I do a star X to do that. So the star X of this, because I just enter the address of itself, when you do the star X, which is the content of that pointer to pointing to, then you should get exactly the value I just entered. Okay, and then you can actually +1, so which means that you can increment the address by 1. So you can see when you run the program. By the way, I want to do another thing, which you to know that I want to print this again, but I want to print using 2 different formats. I want to use LX. Okay, I want to do this one more line. Pointer, compiler. Oh, sorry, I want to do this way. You can actually see how I'm doing this. Escape X, sorry. Escape X, shell. Okay, I can do this and then show you the code at the same time. Hold on. I want to copy this line. Okay, I compile, everything is fine. So I just do /pointer test. Okay, I enter 140732751051120. Okay, so you can see that this is the value, this line over here, the first line here, is exactly the line as this one. It print this value, which is the address. But then the next line I just added, because I use LX, it has a decimal representation. So it's basically it's a 7FF EE5A0, and that has decimal of this value. But now the interesting is about this two line. You see that this line over here, I'm basically using the address of X and I'm casting it as a character star and then +1. Then I'm going to get this value, which is adding 1 in the memory address. But if I actually first add a 1, the memory address of MX, I +1, and then I casting it, I'm actually, I actually increase by 8 over here. You see that difference? And I'm +1, but this two line, there's a huge difference between the value over here.
Professor, what is the casting mean? The character
Okay,
and the asterisk.
casting. Okay,
long-
I'm telling you. Okay, thank you for asking the question. I'm telling you the answer is because you have to understand other people's casting. But casting is evil. I can tell you that casting is sometimes really evil because you can see that this two line, it looks almost the same, but the semantic meaning is different. So let me tell you what casting is doing. Casting is for you to put a different adjective or attribute to a particular variable, such that it will be treated differently by the whoever want to use this variable. I mean, for example, I casting this one. This X is actually a long, right? MX is really what the type of MX is a long star, which means the pointer to a long. But I casting it, I change it to be long. I kind of override whatever the semantic meaning of MX into something else, so I can put into this formatted string MLD, which is printing a long integer. All right, so that's the casting. So in C or C++, you do a lot of casting because when you do casting, it's changing the meaning. In fact, casting in C++ even, I would say is even more dangerous. I will show you later when I talk about inheritance. When you talk about inheritance, virtual function, casting allows you to do something very tricky. So inheritance, I just want to spoil your fun a little bit here. If you casting anything, you thought it's just the type is changing, but the value of MX shouldn't change, right? That's our belief about casting. Casting just changing the kind of type for the compiler to be able to match with something else. But in C++, when you have inheritance, when you do casting, sometimes you change that value as well. You change the memory address from your current pointer to your parents' memory address, because inheritance, the part of memory belong to your parents, part of your memory belong to yourself. When you casting your own pointer, you actually became your parent. So there's very tricky thing, which is right now I don't want to talk about that too much, but later you will see that that's kind of, in some sense, is very powerful. For example, I want to do virtual function, I have to do that. But on the other hand, when you use it, you really have to be very careful. Okay, so let me use this as an example. Let me actually use this as an example. So this one, you can see that the difference between these two is that I first casting this as a let me just cast this part. So to understand, you have to see this part. This is 2 parentheses, 1, 2, yes. These are basically one block, right? I casting MX as a character star. So it means the whole thing is a pointer to character. So when they look at this, they look at this this is a pointer to a character, And what's the size is a one character, is 1. That's why when you plus 1, is actually plus 1. That's why you got this 7, 1. But to look at this is a little bit different. You actually, parentheses should be read this way. If you be careful about parentheses, this is a parenthesis is going to do. And what's mx? Mx is a point to a long, not pointer to a character. And what's the size of is a long? Long is 8 byte. So when you plus 1 is actually thinking about adding another long. So that's why it's adding 8 here. Okay, let me use another example. Let me actually go back to Control X. Oh,
Professor, one more question regarding to this. Eric, if you have a pointer, you need to put where you casting, you need to put the asterisk after the character and asterisk after the long, because
yes, you need to do that. Yeah, you need to do that. That represents. So whatever you said, long star is a type, means that whatever after that is a pointer to that. So the semantics looks like this: is whatever type that you have. This type could be a integer, long, or any kind of struct, or even class. Type star. If you have a type star, that means whatever comes after this is a pointer to that particular type. Do you see my typing on the Emacs window here?
Yeah.
Okay. So now I'm going to do something tricky. If I actually copy this code here. Okay. So if I include this in my program. Okay, and now I have a box struct over here. So what I will do is this. Let me copy this line. I shouldn't do this. So first I will do is I will add a lot of space so you won't confuse. So this is really a single. If you look at this part, 1, 2, 1, 2. Yeah, this is the whole unit, right? So this is you see that this whatever this is like this.
Yeah.
Okay. Now I'm going to change this part to struct box 3 star. I actually make it to a pointer to this structure. Can somebody guess what will be this add 1 will add how many?
1 double is 6.
1 double, I forgot. What is the size? Okay. Let me try to printf. Size of double is equal to %LD, let's assume. That's size of struct box 3. Right? This is just print out the size of box 3. I mean box 3. Okay, let's try to compile this code. Give me back my shell. Okay, let's see if do I get the compiler error? Okay, no compiler error. Fine. Okay, so now I need to wait a minute. It doesn't even allow me to enter my value. That's interesting. Hold on. Something is wrong.
No, I think it's prompting you to enter X after you've already entered it in the program.
Okay, all right. I think you're right. No, I don't want to save this. You know what? I'm going to kill it. Yes, I want to kill it. I'll just do it here. Okay, 140-732-711-094-608. Okay. You cannot be. No, this, wait a minute.
Edges.
Something strange. Something strange. Let me check my code. This cannot be too big. Cannot be that big. What is the size off? Let me check the. There's something wrong with the code. Sorry about that. Oh, I forgot to put. No, I forgot to put \n here. That's why. Yeah. Okay.
4.
Yeah. No. Program is correct. I just forgot the \n. 140.732.716.554.576. Okay, so you see that this one is adding 1, right? The first line is adding 8. But I know the size of box 3 is 24 because double is 8 byte. So 3 variable is 24 byte. And just look at this, hexadecimal. The difference between these two are 1/8, right? Between these two, hexadecimal is 1/8. And what's 1/8 in hexadecimal? 24, right? You see that? So even though I'm just adding 1, but it's actually 24 because I casting the pointer to be a pointer to a box 3. So when I add 1, it will actually increment by the size of that type that just pointing to. So that's why it's adding by 24. Okay. So that's the detail. Sometimes it's very unnatural, to be honest with you. Very unnatural unless you understand the concept of pointer, address, and reference. They're the same thing. So pointer is an integer and pointer is a memory address, but pointer has a reference to a type, which is related to the semantic about the operator plus. So +1 is no longer just +1. It could be +1, +4, +8, or plus whatever the size of the struct or size of the type you're pointing to. Yeah. All right. Any other question? Sorry about that. This took a long time for me to explain this. But hopefully this give you some refresh about your knowledge in C programming. This, by the way, this is one of the hardest topics in C programming. Try to understand this part. Because other than this part, to be honest with you, C is no difference from, say, Java or Python in other perspective. This is a very unique perspective of C, allow you to control something pretty low level. You can control the address. You know precisely what address you're accessing in your hardware memory, and which is why C language is so useful in developing like operating system kernel or embedded system, because you really need to access very low level information about your system. Okay.
Hi, Professor. I have a question.
Yeah, go ahead. Sure.
If I change the box 3, the size, for example, the box 3 size right now is 48, then I +1, will that change to
48.
48? Okay.
Yeah.
So this +1 is follow the size, right?
Right. So let's do this again. Okay. I will just adding. Right. So now I'm double the size, right, to make a 6 variable. And let me do this. I like to do this way. I still call this box 3. I call this box 6, okay? Has a 6 variable. And what I do is this. I change this to box 6. One four 140 732 863 146 320. Okay, now this is the answer, right? So you can see that this one, compare this is 18, right? So 18 is what? 18 is 24, right? But between this two is 30. The difference between the box 6 and 40. And what's 30 has a decimal and transfer to decimal. 30 is 48, right? 3 times 16 plus 0, that's 48. We doubled the size.
Sorry, just to be clarified, it's like +1 will happen in the memory is save the extra space for the new struct, right?
Yes, for the new struct. Yeah, exactly. So that +1, so this is, the +1 is only applied to pointer. Whenever you have a pointer or address, when you +1, it's +1 the size of this part. Either it's a struct box 3 or struct box 6, or it's a character, or it's a long. Okay. By the way, I want to say that this line is really equivalent to. Let me see. Let me try to write this line. This line is really equivalent to long star. Just make it more readable. So I actually think sometimes in this case it's better to put more space here, so people understand that, okay, this casting is a lone star, and because it's a lone star, you're +1, you're plussing 8. Yeah. Okay. Is there any question? We're running out of our time. Is there any question for this class at this moment from anybody?
Hi, Professor. So I have a question about homework 1.
Sure, go ahead.
Yeah, I'm still getting the ID not found problem.
Okay, so who is this? Is Shudron?
Yes.
Okay, can you send me a email, because because this is recording, I don't want to show your ID number. Yesterday I showed the other students' ID number, so I have to edit my video to cut it off. Okay, so send me the Facebook message, and I will deal with that after the end of this class. Okay.
Thank you, Professor. And I
You're
have
welcome.
one more question about
Sure.
the waitlist. So I'm still on the number 4 of the waitlist. Can we get in? Like, is it possible?
I told the department I like to take everybody from the wait list. I don't know what's their issue, but I will ask them. Okay, but I told them I think that last time I checked, every wait list is pretty short. Pretty sure it's less than 5. So for based on my experience, that we will have student drop. So instead of for you to pass the like a drop deadline and do everything again manually, I would say, why don't we just add all of you in at this moment? I think we have a bandwidth to take care of that the way we handle the class right now. Okay, I would double check with the department to say, hey, can you add all the students to clear from the wait list as soon as possible? Okay. But when, by the way, when will be the deadline for I know there's a deadline, which at that deadline, everybody on the wait list will be dropped. Do you know when will that deadline be?
I'm checking, one moment.
Okay, so send that to me also privately. We don't have to deal with that here, but because there might be other students have similar concern, because what I hate is that the student get dropped off from the wait list, and then we have to add manually every student back, which is unnecessary in my opinion. Okay.
Okay, thank you. It's this Friday, April 10th.
Oh, okay. So that's good. I will check with the department. Okay. Any other issue?
Professor.
Yes.
So with homework 1, I couldn't I couldn't make the subdirectory. So all I did was I created the make file, and then I got the JSON and I put it into a text file and I just submitted it. I didn't put it in a subdirectory.
That should be okay. That should be okay, Vishnu. And I will, I mentioned early in this particular session, I said, I will, for this homework, I will only check the log file.
Okay.
But I will give a very detailed instruction for homework assignment number 2 about what you need to do. Okay.
I just had a question, like for homework assignments 2 and onward, I just want to know like how like coding style will play like a role in our grade. Like will there be like a huge role in like, because like last quarter in 36A, like coding style played a pretty major part in our homework grade. And I want to know if it's similar here.
Yeah, I think coding style is we assume you have it, unless let me say we will not deduct the coding style more than 5%. So I'm not giving you a strict coding style you have to follow and then to check on that, but we do want to look at the code. If the code is really sloppy means there's nothing as a structure and things like that. We'll deduct a small portion of the code. But I will discuss with the TA and give you more specific on that. Okay.
Okay. All right. Thank you.
You're welcome.